Do it again. Good. No, I don't even need that. So, okay. So in AWS, you probably know that like everything sits inside of a VPC and there's subnets inside of a VPC. There's all these like networking constructs inside of AWS. What's important though is not the networking constructs per se, but how Kubernetes communicates in AWS is pretty much how Kubernetes communicates overall. So container to container communication, pod to pod communication, and ingress to cluster communication. So what does that mean? In other words, the first two, the container to container and pod to pod, are about how the applications talk to each other. The ingress to cluster section talks about how we outside the cluster talk to the cluster. Okay, so here's the weird thing.
What was the other one? Container to container, pod to pod, and what was the
ingress? So trying to get into the cluster from the outside world. Ingress to cluster.
Okay.
So here's the funky thing, is that every single pod, notice I said pod, I did not say container. Every single pod gets an IP address.
It's not a static IP, is it?
I mean, it can be, but it usually doesn't change. Oh, you mean inside the cluster? No, it's a
no, within the pod, the IP address is assigned to the pod. You said
it's a range. It floats. It's like usually a 172 range.
Okay.
Yeah, because pods come and go, right? So it's going to assign a new IP address every time the pod restarts.
Okay.
So notice the node, which is the host, has an IP address.
Okay.
Notice that it's a 192.168.74 address. So it's a 74 address. Notice that here, instead of using a 172, which is what most of the time it is, they used a 192.168.1 network to set this basically host up, right?
Okay.
Now, what happens, this is where it gets really funky, is that let's say that pod A wants to talk to pod B.
Mm-hmm.
What it does is that this orange box that's around the whole thing, that's a node. That's one host. So what happens is that this guy has a virtual sub interface representing the pod, which has an IP address assigned to it. And what it does is it actually talks to another sub interface that's linked with it. That's on a bridge, if you will. It's on a software bridge inside the cluster. It does not go down to the network card. Instead, the virtual bridge will route to the other IP address. Because pod A has an IP address and pod B has an IP address. And if it doesn't have to leave the host, guess what it's going to do? It's not going to leave the host. In other words, if this is a 192.168.1.1 and the other one's a 192.168.1.2, and it knows that it's on the same host, it's not going to leave. How does it know that? There are route tables all over these hosts. Each host knows what it's hosting, and it knows how to find other hosts who have other IP addresses. So this is why you're limited to 100 pods, is because Kubernetes is orchestrating this ridiculous networking that allows every other pod to find every other pod, no matter how many hosts there are. You follow me?
Yeah. So within the same node, though.
Well, this is within the same node. So what happens when you want to go to another pod that's on another node? Like, I'll get to that in a second.
So this is the pod to pod, right? Communication within the common node.
Within the same host, yeah, same node.
Okay.
Okay. So then, in this particular space, you notice that these are all the IP addresses that are now assigned to these guys. Notice that the pod IP address and like the virtual bridge, they have the same IP address, which is fine. Don't worry about that. Notice though that down here, the host actually advertises that it has 194 and it advertises that it has 195. So in addition to the host saying at this network card, I have my own IP address, I also have all of the pods. So on a host, if you're running 100 pods, there's going to be 100 IP addresses attached to that host. Does that make sense?
Say that one more time.
If you're running 100 pods on a host,
Mhm.
then that host is going to be advertising 100 IP addresses.
Got it. Okay. So
100,
each
101
pod,
technically, right?
yeah, because the host is going to have its own IP.
Exactly, which is what's listed in bold here.
Okay.
Okay, so we haven't even left a host yet. We're still on just one host.
Okay.
Okay, so now what happens when I want to go to talk to another host? So as an example, let's say that I am here at 194. And this, notice this is old .1.194. And I want to talk to .2.195.
Hmm.
So that I'm looking, I got a DNS resolution that said this is the IP address I need to talk to. The pod is going to talk to its virtual bridge, which is going to go through the network card. The network card is going to broadcast out and say, look, I'm looking for 2.195. This host is going to say, look, I got this address. So then this guy's going to go talk to him. And then once it hits the network card with this IP address right here, this guy, the network card's going to say, oh, you want virtual ETH1 bridge. And that's going to direct it to the pod. And by the way, there could be a port. It could be port 80, port 21, port 443. There could be a port here, right? So my point being is that this is how this happens, is that there are IP addresses assigned to every single pod, and that's how the pods find each other within a cluster. Now you might say, well, what if I want to come from the outside and hit that IP address myself? The cluster by default will not let you talk to any pod unless you're coming from inside the cluster. So by default, it will prevent you from talking to anybody in the cluster unless you're coming from inside the cluster. So if someone other than a 192.168.2 or another 196.8.1 tries to get into the cluster, it's going to reject the packet and say your source destination doesn't match the cluster.
Okay.
Say, I'm not accepting it.
And how do you get it? You need to whitelist that, or how do you get around that if you need to?
That's what services are for.
Okay.
Services are service objects inside of Kubernetes. So and there's 4 of them. They're listed right here. Cluster IP, node port, load balancer, and external name. Okay, so this is where this gets interesting.
Okay.
All right, let's say that this is a, let me draw this out. Let's say that this is a cluster. This whole thing's a cluster. And I decide that I'm going to run some of my apps once again, and I'm going to run them inside pods. Okay. So let's say, and I'm going to put them kind of inside the cluster just to, so these are my pods. What happens is that when you create a service, you have to specify the type. What type of service is it? Is it a cluster IP type? Is it an external name? Is it a node port, or is it a load balancer? Now, the thing that's interesting about this is that let's just choose the simplest of the types. Let's say that you decide that you want to do a cluster IP address. A cluster IP address automatically creates an IP address around the cluster IP, and it will allow you to then load balance basically traffic to any of the 3 pods that are attached to that service. So for example, if I have an Nginx deployment and it has 3 Nginx instances, 3 Nginx pods inside of it, if I initiate a service object that's a cluster IP, it's going to talk to all 3 of those backend objects. Cluster IPs, though, only work if you're coming from inside the cluster. They're used for internal load balancing only.
Okay.
Okay, so cluster IPs, which you would think would be externally available, are not externally available. I really wish they had called them something else, honestly, but I wasn't in charge of that.
Okay.
So then you're like, well, then Michael, how do you externalize this so that people can actually hit my web server from outside the cluster? Well, this is where you're going to look at doing something like a node port. Oops, I did not want that. I wanted this. So a node port says on every port in the cluster, I want you to listen on a specific port. And when you listen on that port, I want you to redirect. So let me give you an example. So I'm going to draw some nodes over here on the side. So here's some hosts. Actually, I'm going to use solid for that. Here's some hosts. I got host, 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 host. If I create a node port, and on that node port, I say, look, 192. Actually, you're not even going to put an IP address. You're going to say, look, I want you to listen on port 80886. That means that on port 80886 here, 80886 here, 80886 here, and 80886 here are all going to be listening on that port for this cluster IP address. Right? Because what we've done is we've created a node port, and that means that every node in the cluster is now listening on that port. And if somebody hits the IP address of any node in the cluster, the host IP address, if someone hits the host IP address on any node in the cluster and they hit it on 80886, they're going to get redirected over to the cluster IP address. So all that traffic is going to get redirected to here. And then where does it go after it hits the cluster IP address? Where does it go after it hits the cluster IP?
Goes to the nodes, worker nodes.
Well, to the pods, right? That's what the red is, right? So it goes to the pods. So by the way, to make this a little strange, if one of the pods is here and another of the pods is here and another of the pods is here, it's going to go to whatever one is appropriate. So if it hits a box that already has the pod on there, like it hits the cluster IP, it's going to go ahead and talk directly to that box. If it hits a box that doesn't have the pod on there, it's going to get redirected to another box. So Kubernetes handles all of this for you in the background. So if I hit the cluster IP, it's going to redirect me to whatever available pod is there. And if there's 15 of them, it's going to do all 15, like one at a time, right? If there's 10, it's going to do 10. If there's one, it's going to do one, right? So this is how networking works, is that oddly enough, node port relies on cluster IPs to function. And this is where it gets even worse. Okay, so remember how I said you could start up a load balancer inside of AWS or Azure or whatever and have it function? So let's say that our load balancer is over here. And I'm going to draw this because this is what we're going to do now, is we're going to do load balancer. Okay. So you've got a load balancer, and in that load balancer, www.ilovecats.com is going to resolve to that load balancer. Don't ask. It's not a thing. But I did work for a company that had that domain name, actually. So let's say that traffic comes in and it hits ilovecats.com. This is a load balancer. The load balancer, by the way, could be on the cluster or it could be external to the cluster like it would be on a cloud provider. So for example, this could be an AWS load balancer, right? What's going to happen is that traffic is actually going to hit one of the nodes on this port. Notice I went all the way across to one of the nodes on that port. And it hits the node on that port, and then it's going to talk to the cluster IP address. And the cluster IP address is going to redirect to one of the 3 active pods. So cluster IP forms the foundation. Node port is the next level of foundation. And if you add a load balancer, the load balancer talks to the node port, which talks to the cluster IP address.
So what's the difference between the load balancer that's within that blue section? Because you got a load balancer there too, and then you got an external load balancer.
The only difference there is whether it's inside the cluster or outside the cluster. If it's inside the cluster, it actually still has an exposed IP address. That's different than a pod IP address.
Okay.
Because
But
it's
do
a
you
service.
need do you need an internal load balancer, or can you just do it
No.
outside?
You can do it outside.
Okay.
But and by the way, when you run this in on a cloud provider, by default, the load balancer is external.
Okay.
If you do it inside your data center using VMware, you're going to probably put Nginx or F5 or something on top of your Kubernetes installation.
Yeah, our goal is not to run any Kubernetes on-prem.
Good. I would recommend that, honestly.
Yeah.
Okay.
I'm gonna say I'm not supporting it.
Yeah, I mean, that's probably a good idea. It's like, look, unless you want to help us ramp up with a bunch of experts, you need to expand my team. We're not going to be able to do that. But if you want to run it in cloud, I think that's actually pretty smart. So that's how that works, is that load balancers rely on the node port. The node port relies on the cluster IP address. Now, here's the funky thing. I'm going to take all this away right away. This is going to go away. All right. So this guy right here is not an IP-based system. This is an external name. What that means is that you can actually hit something in like an internal IP address. Let me give you an example. Let's say we're running our 3 apps and they want to talk to a backend database, but the database is RDS. So it's the relational database service on AWS. So it's not inside the cluster. What can happen is that, let's say you've got your 3 apps running over here. You got your 3 pods and they got apps and they're like, man, I really actually need to talk to that RDS database. What you can do is you can create an external name. Oops, that is not what I wanted to grab. You can create an external name which talks to a cluster IP address, which in turn actually talks, in this case, to RDS. I'm gonna use a different color for this, but let's say it's orange, right? That's not what I wanted. So orange. So in this case, it would be RDS, right? So RDS in this case. And so the reason you use an external name is so that Kubernetes can control where the pods look for the DNS, the database server. So in this case, when they go to look for the database server, what they're going to do is they're going to go hit the external name, which is going to hit the cluster IP, which is going to redirect them to RDS. Now, none of this will actually be IP addresses. All of this was IP addresses. This actually will technically be an IP address, but the point being is that it's going to redirect to DNS.
Okay.
It's going to say, hey, go talk to rds.accountname.useast1.blah, at Amazon AWS.com, right? So just know that external name is used when you want to refer to a service that's external to the cluster.
Okay.
Okay.
Yeah, I'm not going to remember this in like 2 months.
That's okay. I won't either. So I look at this all the time. So matter of fact, that's why we have the visuals, because I don't even remember this stuff until I see the visual and I'm like, oh yeah, I know exactly how that works, right? So don't worry, you're in good company. So just know load balancer flows into node port, flows into cluster IP address. The reason this is important for your team is that when they go to troubleshoot, they might be checking out all these objects if there's a networking problem. But I got to tell you, honestly, Bhupinder, if there's a problem with this, you know what you do? You just restart the node. Because that means something's gone horribly wrong with Kubernetes, right?
Yeah.
This stuff doesn't just break itself. You know what I mean?
Yeah, that's kind of what the cloud offers, right? Is you minimize the amount of time you try and troubleshoot because you can restart things really quickly, right? You can spin it down, spin it back up, and hopefully the new version.
Well, because changes are the only thing that make these things broken permanently, right? Like you have to change something. You either have to deploy a bad piece of software or you have to put a bad configuration in there for it to break, right?
Yeah,
Otherwise, to your point, I'm just going to kill this thing and restart it. And guess what will happen? If the configuration's good, which we know it was because it was working before, everything just starts working again. And I know it's
Yeah.
kind of like, well, I want to know exactly what broke. I really don't actually. Because I don't know what kind of cosmic ray flew in here from Jupiter and decided to flip a bit in this memory thing and all of a sudden it went sideways. I'm not going to troubleshoot that. If it's a pattern of failure, to your earlier point about patterns, if it's a pattern of failure, then we should troubleshoot it.
yeah,
But if the thing just went off the rails, forget about it. Let's just destroy it and recreate it.
yeah, yeah.
Yeah.
Yeah, some people get stuck on the RCA too much though, you know, unfortunately.
Well, I think a root cause analysis is good as long as it leads to some learnings. But if you're just root causing analysis because you're like, I really want to know exactly what this was, most of the time you never really know. So you just know what you did to fix it.
Sometimes you don't even know, sometimes it just starts working.
I had that happen with I worked on the Yellow Pages, which was like a huge phone book that was in the Southeast back in like the 90s or something.
Oh, we used to have it here too.
Oh yeah. Oh yeah. I guess they all.
Like
I
you
guess
used to
they
get
all
a
do.
stack like
Yeah,
this big
this-
and
yeah,
drop it in
it's
front
huge.
of your door.
So I used to work on the machine, the Silicon Graphics machine that like generated the phone book and all the entries. And I did some maintenance in the middle of the night and I left and everything was good. Like all the monitoring, everything looked great. This is like 1999, right? I get a call at like 8 o'clock in the morning. Now I want to be clear. I've been up since to 5. So, cause I had to do it during a maintenance window. So it was 3
Right.
o'clock in the morning when I started. They call me at 8 o'clock and I'm like, look, dude, guys, I'm like, what's going on, man? They're like, that Silicon Valley machine doesn't work. I come back over there, by the way, I can see through the history that they've typed these commands. I typed the exact same command that they had just spent 4 hours typing and it booted. And they're like, what did you do? Dude, I have no idea. Who knows? We're moving on. You know, they're like, it's a $10 million machine. I was like, I have no idea. By the way, I'm not really going to go through this, but this goes through all the like the ins and outs. Like if you ever want to look at the video again, but this talks about how kublets and kubeproxy manages the IP addresses and how it looks at virtual interfaces. This gets way too detailed, but this is kind of important. So this is a sample YAML file that includes a service definition. And the thing I want you to notice is look at the type. The type is cluster IP address. So see that? So there's 4 types: load balancer, cluster IP address, external name, and the node port type. Okay. So the rest of this is all just Amazon proprietary stuff. So, okay. Okay. Let's see. There was one last thing. Where were you? All right. I want to talk about storage, and this actually will legitimately be the last thing we talk about. Okay. I just want to talk about storage. All right. So storage.